All right, let's talk about solar panels. You see them everywhere, right? They're practically the ultimate symbol of green, renewable energy. But what actually happens before that shiny panel even makes it onto your roof? Well, in this explainer, we're going to look right past that green label to uncover the hidden and honestly kind of messy complexities of solar panels. And we are going to do this using a highly objective, rigorously structured lens, the SASB industry standards for solar technology and project developers. Basically, these are the exact sustainability accounting standards that companies use to report their real-world impacts to investors. Let's get into it.
Okay, let's dive into this. Here is our roadmap for today. Number 1, the solar energy paradox. 2, dependence on critical materials. 3, the risks of polysilicon. 4, managing toxic waste. And finally, number 5, supplier audits and compliance.
All right, section 1, the solar energy paradox.
So when you think of solar energy, you probably picture, sunshine, pristine blue skies, and absolutely zero carbon emissions. And honestly, once a panel is up and running, that pristine reputation is incredibly well-deserved. But is solar energy 100% clean? Before that clean electricity can actually flow into the grid, we really have to contrast the wonderfully clean energy generated by these panels with the massive global manufacturing footprint required to build the infrastructure in the first place. Because let's face it, solar panels don't just magically appear out of thin air. They require intensive mining, complex chemical processing, and massive global logistics networks.
Moving right along to section 2, dependence on critical materials.
To really ground our investigation here, let's look at the official SASB definition. They define a critical material as, quote, a material that is both essential in use and subject to the risk of supply restriction, end quote. So the really crucial point here is that the solar industry relies heavily on elements that are absolutely necessary for the panels to function, but getting a hold of them creates serious vulnerabilities, mainly because their supply can be so easily restricted. Just picture a mental map of global extraction for a second. We're talking about vital materials like cobalt, indium, gallium, and the platinum group. Now, these essential elements aren't just spread evenly around the world. Actually, they are highly concentrated in very specific geographical regions. And this maps directly to major risks. We're talking physical limits on availability, massive price swings, and intense geopolitical tensions. It's like a giant puzzle where someone else holds half the pieces, making the entire supply chain incredibly fragile to geopolitical leverage. Literally, a single policy change in one country can disrupt global production overnight.
And this brilliantly illustrates just how deep this reliance goes. Check this out. Yttrium, scandium, lanthanum, cerium, praseodymium, neodymium, promethium. I mean, the list goes on all the way to lutetium. It's actually kind of overwhelming to even read, isn't it? But here's the kicker. Every single one of these obscure rare earth elements is identified by SASB as a potential risk factor simply because they are strictly required to make modern solar tech actually function. Which brings us to section 3, the risks of polysilicon. So polysilicon is fundamental. It is literally the absolute heart of most solar panels. It's the semiconductor material that actually allows sunlight to be converted into electricity. But here's the catch. Refining polysilicon requires incredibly intense chemical processes. It's not just a simple matter of digging it out of the ground. It's a heavy, heavy industrial process that introduces severe environmental dangers that these companies have to monitor constantly. Now for section 4, managing toxic waste. If we look at the regulatory text, specifically standard RRSD 440A.2, it requires companies to disclose the, quote, risks associated with suppliers' disposal and handling of manufacturing wastes, including tetrachloride. Tetrachloride is a highly toxic byproduct of polysilicon production, and if this specific waste is mismanaged by overseas suppliers, like if it's dumped improperly or handled without incredibly strict safety protocols, the environmental damage is absolutely severe. So we're faced with this really stark juxtaposition. On one hand, we are sold green energy generation, right? Zero emissions, the promise of renewables. But weighing heavily against that are the manufacturing risks, toxic waste, tetrachloride, and the constant looming threat of environmental noncompliance. It's a striking contrast between the clean energy being sold to you and me and the toxic reality of the manufacturing process that solar companies must aggressively manage behind the scenes. So how do they actually ensure the benefits outweigh those risks? That leads us right into section 5, supplier audits and compliance.
Now, what's really interesting about this slide is how the SASB framework dictates strict corporate accountability through highly actionable steps. Step 1, due diligence and audits. Companies can't just cross their fingers and trust. They literally must verify through rigorous environmental auditing of their polysilicon supply chains. Step 2, strict codes of conduct. This is where they enforce those environmental regulations right in the contracts. And step 3, corrective actions and alternative suppliers. Basically, if a supplier is caught mismanaging something incredibly dangerous like tetrachloride, the company has to have a concrete process to implement corrective actions immediately or completely shift their business to an alternative supplier.
But beyond just environmental audits, companies also have to protect their bottom line from the physical limits and price changes of those critical materials we discussed earlier. So they mitigate these supply risks through a few methods. First, diversification of suppliers, so they aren't overly reliant on one single volatile region. They also use stockpiling. They invest heavily in R&D for alternative materials. And crucially, they make massive investments in recycling. We're talking about specifically designing products for high-value recycling to recover those critical metals and glass at the very end of a panel's life. Wow, okay, so we've covered a tremendous amount of ground today, from the geopolitical concentration of rare earth elements to the toxic realities of polysilicon refining, all the way down to the rigorous audits required to keep it all in check. And I want to conclude by leaving you with this lingering, provocative thought. Can we truly clean up our energy without cleaning up its supply chain? The transition to solar is undoubtedly vital for our future, for sure. But as these standards clearly show us, the true cost of that green label requires constant vigilance and unwavering transparency. Thank you so much for joining me for this explainer. Keep questioning the world around you, and I will see you next time.